Hello everyone, welcome to my channel. So today we are going to do blind 75 on the question reorder list. So as you all know that this is the list which we are following, and I have mentioned this list link in the description of whatever video I am uploading. So now we are left with these videos only, which I have marked as blue, and all other links I have already provided. So you can go ahead with this list and start solving all the 75 questions which are there. And this sheet was not made by me, it was made by someone who was basically working in Facebook, and he figured out all the patterns which are there, and accordingly he has created this list. So I'm just following the list, that is all, and creating videos out of that. So now for today's question, here it is, reorder list. So let us first read this question, then we will be checking for the constraint, whatever possible solution comes to our mind after reading the question and as per the constraint, then we'll implement. I do implementation in C++ because that is my favorite language, and anyhow all other implementations could be found in the GitHub link, which in a lot of videos I have already provided that GitHub link. Else you can go to my GitHub, and there you can figure out there is one repo named as YouTube. Let me show you. So this is although this enhancement is ongoing in this for updating of readme, but basically this is the GitHub repo, YouTube Komal Pal, and here all the solutions are there. Here you can see C++, Java, Python, JavaScript, even in Golang also and C language also solutions are there, although I am not sure why it is not being showing up here. So in this, all the question which I am uploading on YouTube, all the solutions are already here. So you don't need to worry about that from where you'll figure out the solutions. So let us start with this question. Now here, reorder list. You are given the head of the single linked list. The list can be represented as this, that is L0 pointing to L1, then so on. And the last two linked lists are L of n minus 1 pointing to L of n. Now we need to reorder the list something like this, and reordering would be L0 should point to Ln. So basically from these two what we can see is that the first node should point the last node, then the last node should point to the second node. Here you can see, right? So here the first node, that is L0th node, should point to the last node, that is Lnth node. Then this Lnth node should point to the second node, that is L1th node. Then this L1th node should point to the L of n minus 1. Then this Ln minus 1th node should point to the L2, that is the third node of the linked list, and so on the thing should be. So basically here the thing is that whatever linked list is given to us, say something like this 1, 2, 3 and 4, which is here already there. So how we need to link them is 1 should be linked to 4, right? Because this is the first node and this is the last node. Now the last node which was linked with the 1, that should link the second node, that is this one. So now it will be linking this, and the second node which is there, that should link which was just before the last node, that is 3 here, right? So that's why here this is the new linked list which we are required to return. So from this, okay, let me show you one more example. If we are given with 1, 2, 3, 4 and 5, right? If we are given something like this, then how it would be? 1 will be pointing 5, means the first and the last node. Now we need to go ahead with the second node which is there, second and last second node. So first for the second node and then for the last second node. Now we need to go ahead with third and the last third node. So it would be this one. right? So the new linked list would be something like this. So if you observe here with both of these examples, there is one thing in common, that both of them are divided half, and then this particular thing got reversed, and then we are just changing the linking. That is all. Means 1 to 2 is there, then 4 to 3 is there, and what we are doing is we are linking 1 with 4, then 4 with 2, then 2 with 3. That is what all we are doing here, right? So this only we need to do in our question itself. Means whatever linked list head would be given to us, we need to first divide that into half, and whatever second half which would be there, that we need to reverse, and then we need to just change the linking. So basically here the things are in 3 parts. First part is count the size and divide it in half. Divide it in half. This is the first and second part. Then let us see the second part which is there, that is reverse the second half. Reverse the second half of the linked list. And then the third point would be for changing the linking. So these 3 things from the examples which are given, we just observe these 3 things which are there after reading the question and after checking the examples. But one thing which we missed was constraint. Let us check that what the constraints are and if anything will change because of those constraints. So here we see the number of nodes in the list is in the range of 1 to 5 into 10 raised to power 4. Means at max 10 raised to power 4 nodes are there and their values are 1 to 1000. Okay, but anyhow we're not much concerned about what the values are. We are just concerned about the positions of the nodes which are there and the number of nodes which are there. So total 10 raised to power 4 nodes are there, and if we go ahead with n square solution, then it will surely give us TLE, and if we go ahead with n solution, it will work fine. L log n, that will also work fine, but anyhow we are not required with any sort of sorting, so we'll try to figure out that what order of n solution we can go ahead. But as per the algorithm which I have written here, this whole thing will be done in order of n time complexity only, so we can go ahead with the same and code the same. So you just need to keep this thing in mind and accordingly you need to code. And this is the example from which we have deduced this algorithm. So let us start with the coding part, or you can even pause and code by yourself keeping these things in mind, and it's straightforward. Like this only we will be able to do. Okay, then fine, let us start with the coding. So now the first thing is count size and divide it in half, right? So let us first take one pointer, list node star temp, which will be pointing towards the head, so that we can count the number of nodes which are there. Fine. Now while our temp exists, means while temp next is there, that is it doesn't point to the null pointer, till then we will be incrementing our count, and then we will be making our temp equals to temp next, means moving ahead. The way we increment our pointers when we use something in while loop, right? Like that. And we have taken CNT which represents for the count, and we will be starting it from 1 because the TMP which is there, that also we need to count, and we are like directly starting from the checking that TMP next exists or not. So where is that TMP count? That we hadn't counted, right? So that's why we are starting from 1. So after this we will be able to get number of nodes present in the linked list, means the size of the linked list. Now we need to get do the half of this particular linked list, and for that purpose I'll take one more node because this particular half need to be reversed, so that's why I'm just taking it as rev. and it will also be pointing towards the head only. Now the first thing which is there is our mid also. At the start we'll just take it as 0, means just for initialization purpose. And now mid equals to, now the length we have count minus 1 divided by 2. Now comes the part that we need to start our work for reversal part. So for that purpose, this ref node which I have taken, means this ref pointer which I have taken, I need to make sure that this reaches the midpoint of the linked list. So for that purpose, and also I'll take one pointer, let us name it as, because usually take I, let us take it as counter only. Counter equals to 0, and this if we take it as count, because in some of basically in some of the functions we have that count, right? Means in map we have, that's why I usually don't prefer to take count, but fine. So now counter plus plus greater than mid. If that would be the case, then only we will be proceeding ahead with our means basically moving ahead for this rev equals to rev next. So because of this, we will be able to reach at that particular point where our reversing of a linked list can take place, means the middle point of our linked list. That's why we will be going ahead and doing like this. So that would be the case. Now the next thing which would be there is, now after this we will be able to get the midpoint from where we need to start our reversal. So now comes the next point, that we need to reverse our linked list, means the second point, reverse the linked list. Now list nodes, and we'll take rev head, which will return as the reverse linked list head. So that would be the thing, and we need to write a separate function for reversing also, that we will write later, reverse list. And in that what we need to pass is rev next, that we will be passing. Fine. So after passing this, the thing would be in the reversal part of the linked list. So at this point it will, from this point it will start and it will go till end, right? So this particular portion, means this second half of the linked list would be completely reversed because of all that. But even if we are passing this particular to the linked list, but after the reversed linked list come to us, we don't want that particular first linked list which is there, mean the first portion of the linked list which is there, we need it to be separated out, so that we can means later on we can easily change the linking of the linked list. So that's why now what we'll do is, means the rev next which is there, that we will be completely pointing to null. After this, our first and second portion of the linked list are now completely separated out. That's the thing. Now comes the part, means now this these two parts are done, means we have size, and here second part we need to write the function, that will write later. But the next thing, changing the linking, now that we can start. Now the next thing which is there is, we need starting of the linked list, and we need that particular point of the linked list from where it got reversed, means that head of that reversed linked list, basically those two things we require. So for the starting of the linked list, anyhow we can use the previous pointer which we were using, that temp pointer which was there, that we can use. We can initialize that again from the head, because anyhow the temp pointer we won't be using again, that we use just for the counting of the linked list. Now the next thing which would be there is, either we can keep the temp or we can keep this rev head. So now we will be keeping this rev head. So until this rev head is there, till then we will be changing our linkings. Now the way we now the first thing which would be there is we will require one more pointer which will be storing the next portion. I'll draw and show. So now how we will be changing the linking. Before I code, let me show you that also. So now here we have 1 to 2 and 4 to 3, means the reverse part and the forward part. Let me take it more longer one. Let it be 5 and let it be 6. Okay, let me rewrite it. 1, 2, 3, okay, 6, 5 and 4. This is the reverse one, this is the forward one. Now how we need to change the linking would be that one need to point 6, right? Now the thing is that this particular also we should have control over this also, and we should have control over this also, right? So for that purpose what we will be doing is we will be taking a temporary pointer which will be storing this, fine, and for the for keeping control over this we already have that reverse head in which we will be just moving ahead to this 5, so that again it will be having control over this and the whole linked list would be as it is. So that thing we will be going ahead with, and accordingly we will just modify, and then when when we are going to change it something like this, so we need to store this 2 and 3. So this 2 and 3 we will be storing in some pointer, okay, so it would be having that. Then when we change our temps next to this rev head, so it will be having control over this whole thing. That would be the thing. But next, anyhow rev head was storing, means it was having its own control over this whole list, right? So what we'll do is we'll just move the pointer of that rev head, means rev head next equals to, we'll just do something like this, so that rev head earlier which was pointing here, now that will point here, so that it has control over this whole linked list. That is what it would be. So that is what we will be doing. And then next, earlier the temp was pointing here and it got linked to this, but now we want control of this part so that this could be linked to something next, right? So that's why at this point we will move our temp also to temp equals to temp next. So this is what we will be doing, and after doing that our temp would be having control of this also. Earlier it was having control of this and it got linked to rev head, and then now it will be having control over this. So now after having control over this particular, now this 6 could point to anything like 2 or 5, but what we require is that 1 should point to 6 and 6 should point to 2, right? And who is having control over the 2? So this PTR is having control over the 2, right? So because of that purpose, because temp has control over this point, so now temp next would be equals to at that pointer which was having control over this, right? And then we'll move this temp to just temp next, and just by moving this, now this temp has control over this 2 also. So by this means doing these things, we will be able to change the linking, join them together, and even we will be having control over whatever is the next without even completely getting out of whatever portions of the linked list we have. So that's what all we will be doing, and that is what we will be writing here. So now we require a temporary pointer, so that I'm naming it as forward, because here we will be storing the forward, right? So here it will be having temp next, means whatever temp next has the value that we will be storing here. And now we need to change the linking of our temp, so we will be saying temps next should point to rev head, that is to the last point at this point of time when it is just starting, to the last node. And then we need to move ahead with our rev head, and rev head will be equals to rev head next, so that whatever was there next, that control also our rev head have. Now after this we need to change pointing of this temp to the temp next. After this got changed, right? So now it has control over this 6 also, but now 6 need to get connected to 2. So that's why now temp next would be equals to forward. So after this, now temp next has control over this. So now when it has control of the forward, so now temp equals to temp next. So now this 2 which is there, so now at this particular point temp is pointing, right? So because of that, now it need to point to the next node in the reverse list, right? So that all thing will start again in this while loop. So that's why at this point only, means writing our code will stop at this point. And then because of this while loop, again it will start store the whatever forward things which are left in this forward, and it will point towards the rev head. That is what all it will be doing. So this particular portion is done, and we were left with this reverse list function. So we need to complete that. So here, because it will be returning the list node, so list node star reverse list, and we have our head here, list node star, and here we just need to write that previous code only which we were writing earlier. So that all we would be writing. So how we had written earlier, that if head is equals to null, right? So if not head or not head next, then in that case we will be returning head to its parent. And what exactly we are doing is that list node, we require rev head and rev what we say, that we require rev head and rev tail basically. So for that purpose we would be having two nodes. Now rev head, how we will be getting the head of the linked list? So that we will be getting by passing in the function our head next. So whenever it reaches its base case, it will reach to the last of the linked list, right? Then only it will be able to reach the base case, and then it will return to its parent node, and at that point we'll get our head also. And this ref tail which is there, that should have thing, basically that should have that particular node which is the next to the head node, so that we could reverse them. Tail and head should be reversed. Now the ref tail pointing should be changed. अरे क्या हुआ? Now ref tails next, that should be equals to head. We are trying to change the linking which is there, and head next which is there, that need to be null, so that whatever was there in past, that gets eliminated at that point. And then we need to return a ref head. So yeah, reversing of this linked list done, this whole code is done. Now comes the part, let us run this for checking about any of the compilation issues if there is. Yeah, there is. Okay, yeah, we were having this count. I changed the name and I forgot to change it here. Runtime error. Fine, let us figure out. So list node star, everything is there, count starting from 1, while temp next, fine, that is also fine. Then starting from 0, mid equals to count minus 1, that is also fine. And the error is here. Wow. but it was just like, what we say, that just an human error. And here both are green, that means it is accepted. And let us submit it and check if all test cases pass. Yeah, it beats 100%. All test cases passed. So now comes the part for the space complexity and time complexity. So here this is order of n, and again order of n, yeah, this is also order of n. So overall time complexity here is order of n, and space complexity, we are not using extra space, we are just using pointers which are there. So, and that all are pointing to the original linked list only. So overall time complexity and space complexity, so time complexity is order of n and space complexity is order of 1. So this was all for this. If you have any doubt, you could comment that down, and if you think that it could have been done like some other way or something like that, that also you can comment your doubts. And any other method if you know, that also you can comment. And yeah, if you want to contribute for some other language solution for this particular question, you can feel free to contribute on this repo. It's completely fine, you can. So yeah, this was all for this particular video. So yeah, thank you.